All right, we will be working on lesson 9 today on page 47. I'd like you to copy the notes down into your packet. As you're going through this video, please feel free to stop, rewind, and go back if you need to. Example 1, Grandma's special chocolate chip cookie recipe, which yields 4 dozen cookies, calls for 3 cups of flour. Using this information, let's complete the chart. First thing we have to do is create a table. We're going to compare the amount of flour to the amount of cookies. So on your chart, we're going to write amount of flour first and amount of cookies second. That means your flour will be your X values, your cookies will be your Y values. All right, so up above it says that 4 dozen cookies, 3 cups of flour. So let's fill in our first values. 3 cups of flour yields 4 dozen cookies. Now we can enter a second ratio. If we double that, we would get 6 cups of flour and 8 dozen cookies. Keep going, you get 9 and 12. All right, now that we have our chart, let's go to the next box. It's asking, is the number of cookies proportional to the amount of flour used? So all we have is the chart right now, so we want to see if the unit rates are the same. Now remember, to find the unit rates, you're going to do y divided by x. So in the first one, we have 4 divided by 3. So if you take your calculator and do 4 divided by 3, you're going to get a repeating decimal. So we use bar notation, 1.3 repeating. Next one is 8 divided by 6. You get 1.3 repeating again. And 12 divided by 9, which again is 1.3 repeating. So if you have all of the same unit rates, then you're going to write yes. The number of cookies is proportional to the number of cups of flour, because the unit rates are the same. The next box asks you, what is that unit rate? So we already found that unit rate. The unit rate is 1.3 repeating. The second part to that question says, what is the meaning of that in the context of this problem? So in this problem, remember the y value is the amount of cookies. So this is she makes 1.3 repeating dozen cookies for every 1 cup of flour. All right, the next thing we're going to do is graph this. So we're going to use our x on the x-axis, which is amount of flour. And along the side, we're going to do amount of cookies. Remember to put your 0 in the corner. So since we're going up to 9, I think we can just graph these, do every grid line by 1. So I'm going to count every grid line. I'm going to just mark it as going up by 1. We can stop once we get to about 12. And since we have to go up to 12 on the y-axis, I think we can go up by 1s again. So that would be 1, 2, 3, 4, 5. We can go all the way up to 12. All right, so now we're going to do 3 cups of flour is 4 dozen cookies, so I'm going to make a point there. I have 6 and 8. Go all the way up to 8. And I have 9 and 12. If I use my straight edge, I can connect these. And there's our graph. So the next thing says, does this graph show the two quantities as being proportional to each other? So remember, there's two things that happen when a graph is proportional. The first thing is that it is a straight line, which this is, and it goes through the origin, which this also does. So we would write, yes, the two quantities are proportional. Because the line is straight and it goes through the origin. Now it's a good thing that this says it's proportional because we already said yes up here and it's the same problem. Last thing, let's write the equation. Now remember, an equation for a proportional relationship is y equals kx. So let's substitute in our k. So we have 1.3 repeating times x. All right, there's our first example. Let's flip the page and we can go to the next example. All right, example 2 says, below is a graph modeling the amount of sugar needed to make Grandma's special chocolate chip cookies. So let's record the coordinates from the grid and what do these ordered pairs mean? So let's look at the first point. This first point here, it's 2, 3. I walk over to the 2 up to the 3. So the point 2, 3, what does that mean? Well, look, the first number is your x-axis, so that tells us the cups of sugar. The second number is your y-axis, which tells you how many dozen cookies. So 2 cups of sugar makes 3 dozen cookies. All right, let's do one of the other points. This point right here would be 4, 6. So 4, 6 means 4 cups of sugar makes 6 dozen cookies. And we could keep going with each of those points. It means the same thing. So what if Grandma has 1 remaining cup of sugar? How many dozen cookies will she be able to make? So remember, when it's 1 cup of sugar, the sugar is your x value. So 1 cup of sugar would mean that we were finding the unit rate. Now, just a reminder, to find the unit rate, k, we're going to do y divided by x. So pick any point. Say we pick the point 2, 3. Remember, 2 is your x value. 3 is your y value. So substitute in. Y is 3. X is 2. And 3 divided by 2 gives us 1.5. That would be the same answer you would get if you chose any point, if you chose 4, 6, or any of the other 2 points. So the point on the graph, it says plot the point. Now remember, the 1 is your x value. That's down here on the x-axis. This right now is your y value, 1.5, your unit rate. And if you go to 1, that's exactly where that point is, 1, 1.5. So how many dozen cookies can Grandma make if she has no sugar? Well, if she has no sugar, how many cups of how many cookies can she make? She would make 0. So 0 sugar, or 0 cups of sugar, is 0 cookies. So where would that be on the graph above? Well, 0 cups of sugar is your x. 0 cookies is your y. That's the point 0, 0. We call this point the origin. Notice that is also on our graph. So if we have a proportional relationship, there's always going to be 2 points on every graph. One of them is 0, 0. We already know that because we know that it goes through the origin, which is 0, 0. The other point that's always on a graph of a proportional relationship is 1, comma, k. K is your unit rate. That will always be on the graph. Sometimes they'll call it 1, comma, r. I don't know why they call it r, probably for rate, but we've been calling unit rates k, so that means the same thing. All right, so now that we know that, let's go to the next page. This is page 49. And I want you to take a second right now to pause this video and go through the exercise on page 49. It continues on pages 50 and 51. So go ahead and pause the video, work on those pages. When you're done, please come back and check your answers to make sure they are correct. I will be explaining again how to do them. So if you get stuck, you'll have this video as a resource. So go ahead and pause it and try the exercises first. All right, exercise 1 says, can you determine by looking at the graph whether the length of the shower is proportional to the number of gallons? It's a graph, so it is a straight line. It goes through the origin, so our answer would be yes. It is a straight line. That goes through the origin. How long can a person shower with 15 gallons? Well, if you look up at our graph, we are counting here by 5s to get all the way up to 20. So 5, 10, 15. I go up to my y value. That shows me that at 15 gallons, the person would be showering for 5 minutes. How about for 60 gallons? Go up to our y value. That means at 60 gallons, person showers for 20 minutes. All right, look at point A on the graph. Point A, this is 20, so 25, 30, and 10. So what does that mean in this problem? Well, 30 is our x value, so that tells us the number of gallons. 10 is our y value, tells us the number of minutes. So it takes 30 gallons to shower for 10 minutes. Can we use this graph to find the unit rate? Well, we can't go to 1 on this graph because it's in between the grid marks. So we're not going to do that. But there is a way to find the unit rate. Remember, to find a unit rate, we're going to do k equals y divided by x. And you can pick any point. Say we pick 30, 10 from up above. This is our x. This is our y. So 10 divided by 30 is 1/3. So my unit rate is 1/3. I'm going to move that up so you can see that. All right, next page. Let's plot the unit rate on the graph. Now remember, unit rates always fall under the point 1 because that's a unit rate is the bottom number is 1. And 1.5, nope, that wasn't it. 1/3 was our unit rate. So that would be the point 1 and 1/3. Is this point on the line? Well, let's go back and look. If I go to 1, am I at 1/3? I am. So it is on the graph. All right, let's write the equation of this graph. Now remember, it's y equals kx. My unit rate is 1/3. So my equation is y equals 1/3 x. All right, number 2. Your friend uses this equation right here to find the total cost of the number of people. So let's create a table. So we're going to write number of people and total cost. So if we have one person, if I substitute 1 in for P, 50 times 1 is 50, it would cost $50. 2 would be $100. 3 would be $150. 4, 200, etc. All right, part B, is the cost of admission proportional to the amount of people entering the amusement park? So I only have a table, so I'm going to find my unit rates. I'm going to do X divided by Y. Let's say that again. I'm going to do Y divided by X. So I'm going to do 50 divided by 1. That's 50. 100 divided by 2. 50. 150 divided by 3. 200 divided by 4. Notice they're all 50. So that tells us that the cost of admission is proportional to the amount of people. We know that because the unit rates are all the same. So what is the unit rate? We just found that. All the unit rates are the same, so we know that K is 50. So what does that represent? Well, Y values are our cost. So it's $50 for every one person. All right, page 51, we're going to sketch the graph to that now. So our X values are the number of people. The Y value is the cost. Now I only went up to 4 people. So if you skip every other line and make it 1, so basically every line would be half of a person, which we know is not possible, but that's okay. I can spread it out so that it's not all in one section of the graph. Now, the y-axis is the cost, which goes all the way up to 200. If you want to count by 50s, you can, but you're still going to squish it down. So maybe count by 25s. Anything you pick, though, as long as you're consistent, is okay. All right, so one person will cost $50. 2 will be 100. 3 will be 150. 4 will be 200. Now take your straight edge. Draw your line. Notice that my arrow is on the right, but not the left, because you can't have negative people. So the next says, what points must be on the graph? Now we just talked about this. There's 2 points that are going to be on the graph if it's proportional. One of them is 0, 0. That tells us that 0 people cost $0. And the other point that's on the graph, remember, is 1K or 1R. In this case would be 150. So one person will cost $50. So would 5 250 be on the graph? If you go to our graph, 5 250 would be on the graph. So yes, and what it means is that 5 people will cost $250. All right, let's sum this all up. So there are 2 points that are always on the graph if it's proportional. The first point is always 0, 0. And the second point is 1R or 1K, same point. That's 2 points that you have to remember are on a graph only if it's proportional. All right, now that we are done with the notes, if you turn to page 52, this is where your problem set starts. You are going to complete all of the problem sets tonight for homework. It goes all the way through page 55. So you're doing the whole problem set tonight for homework. If you have finished the notes in class, I'd like you to get started on that right now. We will go over that on Thursday when I come back. Thank you.